Welcome to Chapter 5, where we'll be discussing stacks. The objectives of this chapter are to learn about the stack data type. It has four functions: push, pop, top, and empty. We'll learn how C++ implements a stack, and you'll learn how to implement your own stack using underlying array or linked list structures. And we'll see how we can use the stack to perform various applications, such as finding palindromes, testing for balanced parentheses, and evaluating arithmetic expressions. A client using a list can access any element, remove any element, and insert any element anywhere in the list. A stack is different in that you can access and remove only the most recently inserted element, and can insert an element only on the top of the stack. Stacks are a very common data structure used in computer science. Let's learn about the stack as an abstract data type. Stacks are common, and we can compare them to a Pez dispenser. In a Pez dispenser, you can only access the top item, and you can only extract one item at a time. So the top element in the stack is the last one that was added to the stack, or the one that was added most recently. We refer to the stack storage policy as a last in, first out, or LIFO. So only the top element of the stack is visible, so therefore the number of operations performed on a stack are few. So the operations are to test for an empty stack, to retrieve the top element of a stack, remove the top element, and to put a new element on the stack, or push. So here are the C++ function signatures for this empty, top, pop, and push, and we'll also have a function size that returns the number of items in the stack. Here's the header file for stacks. It's included on page 313 and 314 in your textbook. You should take a minute and look carefully through this header file and make sure you understand everything that's there. I'm going to highlight just a few things. First thing is, here in blue, we have a private data field. The field's name is container, and it's a vector. So we're going to use an underlying vector data structure to implement our stack. Notice that stack is a template class, so we can create stacks of holding different data types. And finally, a template class needs to have its implementations here in the header file, and the author puts the implementation in a .tc file that he uses a #include to insert it here in the header file. Here's an example of a stack of strings. So we can create a stack by declaring a variable names. That's a stack of string type. And we can call these 5 push operations that'll push Rich, and then Debbie, then Robin, Dustin, and Jonathan. So here in part A is what the stack looks like after those 5 push operations. Now if we called names.empty on this stack in A, it would return false. And the result of a top operation would place the string Jonathan in this variable last, and it would do it without changing the array. So when we say top, it retrieves the top item of the stack without changing the stack. Now if we say names.pop, then this will remove Jonathan from names, so that then we would have a stack with just 4 items, as in B. Then if we say push Philip, then that'll push Philip onto the top of the stack. And if we called size, we would say the stack has 5 items, as shown in C. And that's the end of this slidecast.